Okay, so welcome back. Today I wanted to go over this page of the homework. Getting started on balancing chemical equations can be a little hard. So I wanted to take time to go over this with you. So our directions say you can tell if a reaction is balanced by counting the number of atoms of each element on each side of the arrow, which means produce, yields, or forms. If the reaction is not balanced, what is the problem? So we look over here on the reactant side, and we see that there are two irons. And then we see that this is a Cl2, and there's three Cl2s. So one Cl2 would be two chlorines, two Cl2s would be four chlorines, and three Cl2s would be six chlorines, which is the same as taking 3 times the subscript of 2, which is 6. Over here in this formula, this says Fe1Cl3. Remember, if there's no subscript, it's a 1. So we have 2 times 1 is 2 chlorines. 2 irons. And 2 times 3 is 6 chlorines. So this is balanced. This one says we have this lithium chloride, and it's going to yield or produce lithium and Cl2. So in this formula, there's one lithium, one chlorine. Over here on the product side, there's one lithium and two chlorines, so it is not balanced, and the problem is the chlorines are out of balance. In this equation, it says this single elemental iron plus, and then there's 3 of this whole compound. So there's 3 H2SO4s. So over here on the reactant side, we have 1 iron, 3 times 2 is 6 hydrogens, and then in the SO4 there's 1 S, but there's 3 of this whole thing, so that means there's 3 sulfurs and 12 oxygens. So remember, there's a 1 here, so 3 times 1 is 3, 3 times 4 is 12. Over here on the product side, we have 1 iron, and then the subscript 3 applies to the SO4. So it says there's 3 SO4s. Remember when we did the polyatomic compounds? Okay, this was 3 times this whole thing. So we have 3 sulfurs, and then 3 times 4 is 12 oxygens, and then 3 times 2 is 6 hydrogens. So this looks like it is balanced. Okay. This one says we have this sodium iodide plus this diatomic chlorine is going to yield 2 salt compounds plus this diatomic iodine. So in this formula over here on the reactant side, there's 1 sodium, there's 1 iodine, and there's 2 chlorines. Over here, because we're making 2 of this whole compound, there's 2 sodiums and 2 chlorines. And then in the I2, there's 2 iodines. So this is not balanced. And what's the problem? Okay, which elements need coefficients? Well, the sodium and the iodine need coefficients because they're the ones that are the problem. This one says this zinc plus this lead nitrate, and you see there's a subscript of 2 on the nitrate, so there's 2 of the NO3s. It's going to yield this lead and this zinc nitrate, and there's also a 2 on the outside of this parentheses. So the 2 goes to everything inside the parentheses. So over here there's 1 zinc, and then in this formula there's 1 lead, and because there's a 2 on the outside of the parentheses and then 1 here by the nitrogen, it's understood. So 2 times 1 is 2, 2 times 3 is 6. Over here on the product side, we have 1 zinc, and then there's 2 times the N, so there's 2 nitrogens. 2 times the 3 is 6 oxygens, and then we have 1 lead. So we look to see if they're balanced. 1, 1, 1, 1, 2, 2, 6, 6. So this is indeed balanced, so there's no problems over here. Okay. It says 2 of the C2H6s, so it's 2 of this whole formula, plus 7 of the diatomic oxygen is going to yield 4 carbon dioxides plus 6 water molecules. So remember, the coefficient goes to the whole molecule. The coefficient goes to the whole molecule. So to figure out our carbons, we say 2 times 2 is 4. 2 times 6 is 12 hydrogens. And we have 7 times 2 is 14 oxygens. Over here on the product side, remember that if there's no number, there's a 1. So 4 times 1 is 4 carbons. 4 times 2 is 8 oxygen. And over here in the water, we have 6 H2Os. So 6 times 2 is 12 hydrogens. We had these 8 oxygens from the carbon dioxide, but we have 6 times, and there's 1 oxygen here, so 6 times 1 is 6, 8 plus 6 is 14. So this does again look balanced. There's 4 carbons on the reactant, 4 on the product, 12 hydrogens, 14 oxygens, 14 oxygens. So yes, this is balanced. Whew. Okay, we have 2 SbCl, so it's 2 of this whole molecule or this whole compound, plus 3 H2S's, so hydrogen sulfide, and we have 6 HCl's, and then this Sb2S2. So we're going to count now, because we have 2 of this whole formula, we have 2 Sb's and 2 Cl's. And then we have 3 of the H2S's. So we have 3 times 2 is 6 hydrogens. And there's a 1 there, so 3 times 1 is 3. Okay, we have 6 of these hydrochloric acids. So 6 times 1 hydrogen is 6. And 6 times 1 chlorine is 6. And then in this formula, there's 2 Sb's and 2 S's. So this is not balanced. Okay, we have the Sb's balanced, the chlorines don't balance, the hydrogens balance, and the sulfur's balanced. So what's the problem? What things where we start putting coefficients? We would start putting coefficients for the chlorine and the sulfurs. Those are the 2 that are not in balance. This says this copper, this elemental copper, plus this diatomic oxygen, this O2, is going to make 2 of these copper oxide compounds. So we have 1 copper, we have 2 oxygens. Okay. Over here, we have 2 of this whole compound. That means we have 2 coppers and 2 oxygens. Remember, it's kind of like multiplying. There's 2 times 1 and 2 times 1 is 2. So is this balanced? No. The problem is there's not enough coppers. So we would start by adjusting this coefficient. Put a 2 over there. We have this aluminum plus this chromium oxide is going to yield or produce this chrome plus this aluminum oxide. So we look over here. Remember, there's a 1 here. 2 times 1 is 2 aluminums. And then in this chromium oxide, we have 2 chromes, 3 oxygens. And on the product side over here, we have 1 chrome. And in the Al2O3, we have 2 aluminums and 3 oxygens. So it's not balanced. The chromes are not balanced. So we would start trying to put a coefficient in front of the chrome to get that into balance. Okay. This last one, we have this aluminum oxide. It's going to break down and decompose into aluminum and oxygen. Okay, so in the Al2O3, we have 2 aluminums and 3 oxygens. It's going to yield or produce 1 aluminum and 2 oxygens. So is it balanced? Oh, no. This one is not balanced either. Okay. And what's the problem? The aluminums are out of balance. And the oxygens are out of balance. So we would start by having to adjust coefficients. And that's all there is to this exercise. So we'll pick up here next time. I'm hoping you have a great day, and we'll see you soon.